In this video, we explain what it means by a geometric series converging. Consider geometric series 1 plus half plus a quarter plus 1 over 8. We can see the common ratio is r equals to half. Therefore, the sum of the first n terms, Sn, will be a 1 minus r power n over 1 minus r, substituting in a as 1 and r as half, and upon simplifying, we'll get this expression as the sum to n terms of a geometric series. Now, suppose I examine the series with the help of a graphic calculator. We will see that if we key this expression for sum to n terms of geometric series into the equation editor of the graphic calculator, and we proceed to look at the values that this function generates. Oops, that's the graph. Let's see. Yes, let's look at the table. Now, in this table, y1 is the value of Sn when x represents n, the number of terms added to the geometric series. So when x equals to 1, we find that we only have sum of the first term, that's 1. When s equals to 2, this is actually s2, sum of the first two terms, and we have 1.5. So when x equals to 3, we sum up the first three terms, we got 1.75. And as we add more and more terms of the series, we find that the values increases to 1.98, 9961, 1.999, 1.9995, and so on until, whoops, hey, the values actually get so close to 2 that you find that after some time, the sum to n terms, when n's get larger, the sum to n terms becomes a constant value of 2. Now, in this case, we say that the series, the sum of the series gets closer and closer to 2, and we say that the series is convergent to the sum 2, or the sum to infinity of the series is 2. Now, when will a geometric series be convergent like this? To explain that, to look at that, let's look at this situation, these three different situations for different values for r. Now, when r equals to 0.1, a value that is positive and less than 1, we find that as we increase the power of r, the values of r power n actually get closer and closer to 0, approaches 0. When r equals to negative 0.1, for example, which is a value that is bigger than negative 1 but less than 0, we find that as the power of r gets larger and larger, the values again approaches 0. The value of r power n approaches 0. But how about when r equals to 2? As n's get larger, the value of r power n gets larger and larger and approaches infinity. Let me say it again. In the first case, the value of r is bigger than 0, less than 1. For the second case, the value of r is less than 0, bigger than negative 1. For the third case, r is bigger than 1. Now, we see that when r takes values between negative 1 and 1, or when we say mod r is less than 1, we have the values of r power n getting closer and closer to 0 as n approaches infinity. Because of this, when we look at our sum to n terms, which can be simplified to a over 1 minus r minus ar power n over 1 minus r, when we multiply a in, we will get this. And when n tends to infinity, r power n tends to 0. For the first two cases, we find that this r power n will approach 0, and the whole term here will be gone, leaving the sum to n terms as a over 1 minus r. Therefore, we say that the sum to infinity is a over 1 minus r. And the sum to infinity exists provided the value of r is between negative 1 and 1. Now, please note that the sum to infinity for an AP is not defined. We do not say sum to infinity of an AP. That's the end of this video. Thank you.